Start the class. Okay. Good evening. Welcome to your study part. And this is chemistry class. I trust your day have been great and your day have been very productive. Okay, so let's start off. Last week we considered chemical combination, right? And we ended up by answering some practical questions, some jam past questions. And I made mention that we'd continue from that point. So let's consider some questions and then we'll move on to a fresh new topic. The first question here is how many molecules are contained in 1.12 dm cube of hydrogen gas at STP? Just a brief like recall. We all know that what STP. I made mention is standard temperature and pressure. And I also made mention of molar volume, which is 2.24 dm cube. And if it's in cm cube, you multiply by 1,000. We also came to a conclusion of some terms used to define some ways to define mole. That's in terms of volume. You can use volume, you can use Avogadro's constant, and we can also use given mass over molar mass. And so basically the questions, this set of questions will just be around mole, basically around mole using one or two formula. So we can either use one or two. I made mention that you can use two because it will still give you the same thing, right? And so let's consider this first question. How many molecules are contained in 1.12 dm cube of hydrogen gas at STP? I made mention that mole is equals to given volume over molar volume, given volume over molar volume. And at STP, the volume is known, and the volume is known to be 2.24 times 2.24 dm cube. And so we are given a volume of 1.12. So 1.12 over molar volume, which we already know at STP to be 2.24. This is dm cube, and this is also dm cube. And so the answer we get here would be our answer. That should be 0.5. But let's punch our calculator to confirm that. Divided by 2.24. That's 0.5. So 0.5 moles. Simple. So we just basically used only this formula. Let's consider the next question. How many atoms are present in 6-gram sample of carbon? Carbon is C. That's the chemical formula of carbon is C. The atomic number of carbon is 12. Atomic mass, the atomic mass of carbon is 12. Carbon is the sixth element on the periodic table. Hydrogen, helium, lithium, beryllium, boron, carbon. So carbon is the sixth element on the periodic table. Its atomic number definitely will be 6, but its atomic mass is 12. So back to the question, how many atoms are present in 6-gram sample of carbon? We are given Avogadro's constant, which is 6.02 times 10 raised to power 23. We are told to calculate number of atoms. We are given this constant, we know the mass, and we know the atomic mass. We can work around that. First off, we'll calculate the number of mole, and for mole, since we already know this, we have this, we can calculate the number of mole, and from the number of mole, we can calculate the atoms using this constant. So mole equals to mass over molar mass. Here we are dealing with only one atom, so it will be atomic mass. The given mass is 6, so 6 divided by 12, and that would be 0.5 moles. From here, we can move on. We also know that mole is also equals to number of particles in this case atom divided by 6.02 times 10 raised to power 23. So number of particles here, that's what we are told to calculate. We already know mole because we calculated it from here, right? And we know this. So we can say number of particles equals to this times this, mole multiplied by 6.02 times 10 raised to power 23. The calculated mole is 0.5. So 0.5 multiplied by this value 6.02 times 10 raised to power 23. So let's punch that. 0.5 multiplied by 6.202 times 10 raised to power 23. And that is 3.01 multiplied by 10 raised to power 23 atoms. Because we are told to calculate the number of atoms. So this is our answer. 3.0. So let me write that 0 well. 3.01 times 10 raised to power 23. Let's consider a few more questions before we then move to today's topic. Okay, so let's start off with it. Let me drop this. Let me close this. All right. 2015 question 26. 2015. 2015. 26. Okay. 24 gram of magnesium Mg reacts with dilute hydrochloric acid, which is HCl. Full stop. Calculate the volume of hydrogen gas evolved at STP. We're given magnesium atomic mass to be 24. Molar volume of gas at STP equals to 22.4 dm cube. I told to calculate this. Okay, so let's repeat the question. 24 gram of magnesium reacts with dilute HCl. Calculate the volume of hydrogen gas evolved at STP. So, first off, what do you think that reaction would look like? What do you think the equation of reaction will look like? Magnesium plus HCl. That's reaction of acid and what? And a metal. And this should give you MgCl2 plus hydrogen. MgCl2 plus hydrogen. So let's balance this equation. So we just basically need to put 2 here. We're not given the equation, but we already know that magnesium is a group 2 element, and so it will come out to be this, and then hydrogen will be involved. We're told that the volume of hydrogen gas evolved. So this is the hydrogen that would get evolved in the process of the reaction. Let's go back. We have the mass of magnesium known. We have atomic mass of magnesium known. We have molar volume. We're told to calculate volume. What do you think we can do with this information we have? Since we have mass and we have atomic mass, we can find number of mole. And with mole and molar volume, we can find the volume. That's the volume of the hydrogen gas. So let's pick it up from there. Mole equals to given mass over molar mass. Magnesium, we're told 24 grams. Apparently, atomic mass of magnesium is also 24. So 24 divided by 24 will give 1. And so that is 1 mole. With this information, we can move ahead. Well, since we know that mole is equals to given volume over molar volume. If measured at STP, it's 2.2, 22.4. So given volume, which is our question, will then be mole multiplied by molar volume. Calculated mole is 1. Molar volume is a constant, 22.4. And so 1 times 22.4 will give 22.4. And the unit here would be dm cube. since we're told to calculate volume. Simple. Let's consider a few more. Let's move on. I'm sure I can clean this now. Okay. What mass of water is produced when 8.0 gram when 8.0 gram of hydrogen reacts with excess oxygen. Right? The first thing to write would be equation of reaction. Reaction of oxygen plus hydrogen. Oxygen plus hydrogen to give water. This equation is not balanced. 2 here, 2 here. Right? And we are told 1 mass of water is produced when 8 grams of hydrogen reacts with excess oxygen. Here, we know that atomic mass of hydrogen is 1, right? So 2 into bracket 1, 2. We can say that since hydrogen is the limiting reagent, we'll just work with hydrogen because we are told excess oxygen. I'm sure we all know what limiting agent is. And so let's move on to this. Since this is the limiting reagent, we'll work with that. And then let's move on to water. Yeah, 2, this is 1, 2 plus atomic mass of oxygen is 16. And this is, so 2 into bracket 2 plus 16. That's 2 into bracket 18. And that is 36 grams. So, and this is 4. That means 4 grams would produce 36 grams of water. So 4 grams of hydrogen can produce 36 grams of water. From the equation of reaction, we can deduce this. Now, what would this produce? 8 grams of hydrogen will then produce how many grams of water? With this, we can do cross multiplication. So it will be 8 multiplied by 36 divided by 4. 8 multiplied by 36 divided by 4. And let's work with that. 8 multiplied by 36 divided by 4. And that will give 72. And so 8 grams of hydrogen would produce 72 grams of water. How were we able to get that? Because we know our balance reaction. From our balance reaction, we know that 4 grams of this will give this. Since we are told that oxygen is in excess, so we didn't have to involve oxygen at all. Because since oxygen is in excess, one of them has to be the determining factor, and that is what's called limiting reagent. Here, hydrogen is the limiting reagent for this reaction, and that's what determines what goes in the system. So let's move on. My duster. Okay. Okay. 220 gram of carbon dioxide contains dash moles. 220 gram of carbon dioxide contains dash moles. What do we do? Carbon dioxide can be written as CO2. CO2. Carbon monoxide is CO and is also called CO or carbon monoxide or carbon 2 oxide. And carbon dioxide is CO2 or carbon 4 oxide. The question says carbon dioxide, so that is CO2. We can calculate the molar mass. We're not giving atomic mass in the question, but everyone on this call must have gone through SS1, SS2, and SS3. So there are some basic elements you should know the atomic mass. Like carbon. Carbon is 12. I'm sure we all know that. Oxygen is, guess. Oxygen is 16. So that's 12 plus 2 times 16, 32. And that is 44 gram per mole. Right? So let's move on. We're told to calculate the number of mole. Mole is equals to given mass over molar mass. All right, so mass here 220 divided by molar mass 44. The value here is the answer. So 220 divided by 44, and that is 5 moles. So this is the answer. I think the next question, I'll give every one of us on this call like few minutes to answer, and then I answer it so that you will be able to validate yourself if you've been following this class and if you already know what we are saying, and it's not that I'm just playing around. So the question is the volume occupied by 1.58 gram of a gas at STP is 500 cm cube. Full stop. What is the relative molecular mass of the gas? Question mark. We're given GMV at STP to be equals to 22.40 dm cube. What volume occupied by 1.58 gram of a gas at STP? Oh, sorry. The volume occupied by 1.58 gram of a gas at STP is 500 cm cube. What is the relative molecular mass of the gas? Let's try this. And I'll be giving us 2 minutes. And then we'll answer it together. So just try it and then we'll validate it with the answer I get.
More likely, like plenty in that case. Because of this investigation, this is showing on this side.
All right. I'm sure you've gotten your answer right now. Okay. Let's answer it together. The volume occupied by 1.58 gram of a gas at STP is 500 cm cube. So from here, we know that mass is equals to 1.58 gram. Volume at STP is equals to 500 cm cube. Emphasis on the unit cm cube. What is the relative molecular mass of the gas? So we are told to calculate molar mass. And we are given molecular volume at STP, right? To be what? 22.4 dm cube. From here, you can see cm cube and dm cube don't match. And then, so we have to convert one of them to the other. So, from these two information, we can calculate the mole. And then with this, mole and this, you can calculate molar mass. So, let's do that. Mole is equals to volume over molar volume. 500 cm cube divided by molar volume. Molar volume here is 22.4, but the unit is dm cube. To convert dm cube to cm cube, you multiply by 1000. To convert dm cube to cm cube, you multiply by 1000. To convert cm cube to dm cube, you divide by 1000. So let's convert dm cube to cm cube. So that's multiply by 1000, right? So let's punch that on our calculator. 520.4 multiplied by 1000. And that is 0.02